We're going to go over workbook pages 121 to 130 in your iReady Math. These pages should already be completed, all of 121 through 130. We're not going to go over all of these problems. We're going to go over, I think, 10 of them today. I picked the best problems or the hardest problems to go over because I want to make sure that you understand those problems. Even though I'm not going over every single problem from 121 to 130, you still need to make sure that all of the problems are completed. It is your responsibility to make sure they're all complete because you will turn in all of those workbook pages when you come in for your test day. So the first problem that we're going to go over is actually on page 122. You should have your workbook in front of you following along. If you have mistakes, you need to correct them, and if you miss something, you need to email me if you don't understand why. So the first one we're going to go over is page 122, and it's problem 8. So problem 8 says dividing a number by 10 is the same as finding 1/10 of a number. Use the phrase 1/10 of or the phrase 10 times to complete each statement about 1,000th. So before we go over what the exact answer is, you should have, let's see if I can show part of this and not all of this. We'll start there. That's the first problem on 8. You're comparing 1,000th to 100th. Since 1,000th comes first, that's the one that you highlight. 1,000th is to the right of 1/10. So when we move to the right, that should be 1/10 of. Alright, then it got a little bit harder because it asked us to compare 1/100th and 1/1000th, but they wrote it as a fraction. So we had to take 1/100th and write it as a decimal and take 1/1000th and write it as a decimal. So 1/100th comes first, so we should highlight the one that comes first in the problem always. And since that highlight is to the left of the not highlight, that's going to be 10 times. Oops, times. There you go. So number 8, the first blank should have had 1/10 of, and the second blank should have had 10 times. But you need to show your work where you line up those decimals, just like I showed you a second ago. Alright, number 9 on the same page is multiple parts. So it says, in which number does the digit 5 have a greater value, 5/100ths or 5,000ths? So that's one question. Which digit has a greater value? How many times as great is the value? That's a second question. And then explain how you know. That's a third question. So you need to make sure that you answer all the parts of the question. Again, before we look at our answer, we're going to look at work for number 9. You're comparing 5/100ths to 5,000ths. Since 5/100ths comes first in the problem, that's what you highlight. So it wants to know, the first question was which one's bigger. Well, since 5/100ths is to the left, 5/100ths is the one that's bigger. So 5/100ths is bigger. How much bigger is it? Well, how many times did we move from this digit 5 to that digit 5? We moved once. Now, is that 1 times bigger? No, because every time we move on a place value chart, it's not, even though we move 1 time, every time we move is times 10. So it's 10 times bigger. And then how do you know that it's 10 times bigger? Because I moved 1 place to the left on the place value chart. Alright, so let's look at the answer that they have in our answer key here. Well, let's move this. So we said 5/100ths was bigger. How much bigger? It was 10 times as much. And then you had to explain that. The digit in 5/100ths is 1 place to the left of the digit in 5,000ths. And each time we move to the left, it's 10 times as much. You don't have to have the exact answer they have here. You do have to make sure you answer all 3 parts, and your answer should be similar. The next problem we're going to do is on page 123, number 2 at the bottom. We are asked to compare 1/10 and 1/100th, but they are written as fractions, so we have to take them and write them as decimals. So 1/10 as a decimal is this, and 1/100th as a decimal is this. We're asked to compare them. Since 1/10 comes first, we highlight 1/10. Since our highlight is to the left, that's 10 times as much. The next part of number 2 asks us to compare 1/100th to 1/10th, but this time 1/100th comes first. So we highlight 1/100th because it comes first in the problem. The highlight is to the right of the not highlighted number, so that's 1/10 as much. So on the first blank you should have had 10 times, and on the second blank you should have had 1/10 of. Make sure you line up those decimals just like I showed you a second ago so you can show your work. The next problem that we're going to go over is on page 126, and it's problem number 7. Problem number 7 says, how many times as great is the value of 1 5/10 than the value of 15/100? And it says explain. So we want to know how many times greater, and we want to explain how we know that. You need to show work by lining up those decimals. 1 5/10, 15/100. Since 1 5/10 comes first, that's the one we highlight. We're going to compare these ones. Since my highlighted one is to the left of my not highlighted one, it's 10 times as much. How do I know, explain why it is 10 times as much? Well, it's 10 times as much because it's one place value to the left. So let's look at their answer that they have. They have that it is 10 times as much. Each digit in 1 5/10 is one place value to the left of where it is in 15/100. And when digits move of one place to the left, its value is 10 times more than it was. You don't have to have their exact answer. You do have to answer both parts, and you should have something similar to their answer. The next problem we're going to go over is on page 127. 127, it's going to be number 3. Number 3 was a pattern, and it wanted us to use dividing by 10 to complete the pattern. So our digits should have moved one place value to the right every time since we were dividing by 10. So 400, we move them all to the right, that makes it 40. We move them all to the right, that's 4. Then 4/10, 4/100, 4/1000. Every time we move all of our digits one place value to the right. The next problem that we're going to go over is on that same page, number 4. How are the decimals 9/1000ths and 9/100ths related? Explain. So this one's a little tricky because it just wanted you to explain how they're related. So I wrote it like they had it in the problem. I put 9/1000ths, 9/100ths. Since 9/1000ths came first, it was to the right, it was 1/10 as much. So 9/1000ths is 1/10 the value of 9/100ths. And I know that because my digit moved right. But it just wanted me to tell how they were related. It didn't say how is 9/1000ths related to 9/100ths. It just said how are they related. You can explain it any way you want to. So you could have also said, you could have done it the other way and said if 9/100ths came first, that was moving to the left, so you could have said 9/100ths is 10 times the value of 9/1000ths because the digits move left. Or you could have said 9/1000ths is 1/10 the value of 9/100ths because the digits move to the right. Either one of those answers is acceptable. You can pick whichever one, and that's fine. You don't have to put them both down. So either 9/1000ths is 1/10 the value of 9/100ths because the digits move right, or 9/100ths is 10 times the value of 9/1000ths because the digits moved left. The next problem we're going to go over is number 5 on page 128. Number 5 on 128. Wanting to know which expressions were equivalent to 700ths. So you should have worked out all of the expressions. So the first two were 7 thousandths times 10. All the digits move left one place and you get 700ths. 7 tenths divided by 10. All the digits move right one place and you get 700ths. So both of those were equivalent to 700ths. The next two on number 5 was 700ths times 10, which means all the digits move left one place and you got 7 tenths. And 10 thousandths divided by 10. So all the digits moved right one place and you got 700 thousandths. Number 7 on that same page, Ethan says that the value of 40 and 7 tenths is 10 times the value of 4 and 7 hundredths. Is he correct? Explain. So you need to answer yes or no if he's correct, and then you need to explain why he's correct or why he's wrong. So you should have taken 40 and 7 tenths and 4 and 7 hundredths and lined them up to show your work. Since he's saying that 40 and 7 tenths is 10 times as much, we're going to highlight the 40 and 7 tenths first because it came first in the problem. Our digit moved left, so looky there, he is correct. It is 10 times as much. How do we know? Well, we know because the digits moved left. All the digits in this number, 4 and 7 hundredths, moved left one place value to 4 and 7 tenths. So yes, he's correct. Each digit in 40 and 7 tenths is one place to the left of where it was in 4 and 7 hundredths. We know when we move left, it's 10 times the value. You don't have to write exactly what they do. You can write it in your own words, but make sure you have both parts answered. We're going to go over number 8 on that same page. Maya says the value of the 6 in 6 thousandths is 1/10 the value of the 6 in 6 tenths. Is she correct? Explain. So Maya is comparing 6 thousandths to 6 tenths. Since 6 thousandths comes first, we're going to highlight 6 thousandths. It does move to the right, but it moved to the right 2 times. So she's just saying this is 1/10 the value. No, she's not correct. It would only be 1/10 the value if it moved right one place. 6 hundredths is 1/10 the value of 6 tenths. But 6 thousandths is actually 1/100th the value of 6 tenths. So you could have written like they did. No, she's not correct. 6 thousandths is 1/10 of 6 hundredths, not 6 tenths, because the 6 in the 6 thousandths has 1/10 the value of the 6 in 6 hundredths, not 6 tenths. Or you could have said that she was not correct because the value of 6 thousandths is 100th the value of 6 tenths. She put 1/10, but it's actually 100th. So you can explain it the way I just showed you that was in the book, or you can explain it by telling me that it's 100th the value, not 1/10 the value. The next one that we're going to look at is on page 130. We're going to look at number 4. You had to take the mass of an ant, a bee, and a grasshopper and put it in the place value chart. That should have been fairly simple for you just to write those digits there. In part B, you had to shade the model to show the mass of the grasshopper and the mass of the bee. So it should have looked like this when you shaded. 5 hundredths for the grasshopper and 5 hundredths for the bee and 5 tenths for the grasshopper. Also on part B, it wanted you to write a sentence to describe the relationship between the mass of the bee and the mass of the grasshopper. So you should have written your decimals for the bee and the grasshopper on top of each other. Since the bee comes first, we're comparing the bee to the grasshopper. We highlight the bee. The bee is to the right, and since it's to the right, that would be 1/10 the value. So the bee is 1/10 the mass of the grasshopper. So if we look at the answer here, The mass of the bee is 1/10 the mass of the grasshopper. We're going to look at part C, which asks you to explain how many ants it would take to equal the mass of one grasshopper. It also wanted you to write an equation using the measurements to show your answer. So we're comparing the ant to the grasshopper. So again, you should have showed work on your notebook, on your workbook. You have the ant's mass as 5 thousandths and the grasshopper's mass as 5/10. Since we're comparing the ant to the grasshopper, we highlight the ant. The ant moved to the right, but the ant moved to the right 2 place values. It wasn't just one place value over. This 5 that was in the tens place went to the hundredths and then to the thousandths. So moving right is division, but it's not dividing by 10, it's dividing by 100, or 1/100th of the value. So how many of these ants would it take to equal one of these grasshoppers? It would take 100 ants to equal just one of those grasshoppers. 5 thousandths times 100 is going to equal 5/10. So if we look at our answer here, this is just a possible answer. Since 10 ants have the mass of 1 bee and 10 bees have the mass of 1 grasshopper, the mass of 10 times 10, or 100 ants, would equal the mass of 1 grasshopper. You could simply put 100 ants would equal 1 grasshopper. It did ask you to use an equation to show your answer. They have 5 thousandths times 10 times 10. That to me is a little confusing. What do you know 10 times 10 equals? So I would have simplified the answer and put 5 thousandths times 100 equals 5/10. So you could have simplified your equation by doing this, but you did need to tell me that 100 ants would equal 1 grasshopper. If you missed something and you don't understand why, please email me.